Well, hopefully you enjoyed that video where this woman was apparently a doctor, a mom, a teacher, like all these things, and making her testimonial about all these products and how they work in her unique circumstances, which are apparently all the circumstances. We really can't trust the source of testimonials. And so hopefully you guys knew a lot of those things already. So even though I think the average person vaguely knows a lot of those problems with testimonials, they still are very persuasive. They are the best way to get people to buy things, have somebody like them sell the product, right? So why are they so persuasive? Well, for one reason, testimonials are vivid, right? You see a case saying it worked for me, and you think, man, I want it to work for me, right? This person seems somewhat like me. Maybe it would work for me also, right? So the fact that we can see them, hear them, relate to them, they're much more vivid. And so we believe it more. Now, one person's story affects us more than data does. Like if we have Laura telling us that she lost 6 pounds a week by taking Proactol, and then you have somebody telling us statistics about how the average person lost this number of pounds, Laura's going to affect us more, right? It's going to make us think that she's more credible because we can see her, she's putting her face on it, things like that. You can kind of relate to this if you've ever asked a friend, have you ever had this professor before? What did you think of them? Asking your one friend what they think about a professor, instead of looking at the student evaluations that are kept in the department that you're more than welcome to go rifle through. It's a lot easier to ask your friend for one thing, but also your friend is somebody who you know, you trust. You figure if you like each other as friends, then you probably would like other things in the world in common. So their experience with a professor would probably be similar to yours. Even though the data would probably be much more informative, seeing what the average student thought, seeing comments that students might have generated, things like that, that might be way more informative. One person's story is going to be much more impactful for us. So we'll probably take our friend's advice, even if the data suggests that our friend is in the minority. So also, by the way, I would like to point out that Rate My Professor has a small problem with its rating scales in the sense that really only most motivated students go there. So like the people who are really, really mad and the people who really, really liked it seem to be the only ones who ever go to Rate My Professor. So the most informative student evaluations probably would be the ones that are housed at the department. But most of us don't bother to go look at those before we take a class. We ask somebody else who's had that professor before, how's this class going to go and things like that. And it's a good example of how a testimonial can persuade us. When we talk about vividness effects, what we're talking about is something concrete versus something abstract. Abstract information does not sway us as much as we would think it should. Seeing these numbers or this data doesn't sway us as much as seeing a case, an individual. So I thought I'd illustrate this with some kind of shocking examples. So brace yourself. It's kind of shocking. It's really shocking. The U.S. debt clock. So over here in the top left corner, you see the U.S. national debt spinning like a roulette wheel, adding debt as I speak. It's at 24, blah, blah, blah. When I first started doing this in 2010, that number 24 was 9. So I get horrified every quarter. I'm like, how much more has this gone up? But seeing it spin and seeing those numbers, and you notice how I called it 24 blah, blah, because I want to call it 24 billion, right? But it's 24 trillion. But once you start getting past million, you lost me anyway. Like what's it like? How can I even concretely imagine a billion? It's just so much. It's just so much. When I was in undergrad, I took physiological psychology, and my professor was trying to impress us with how many neurons are in the brain by saying there are as many neurons in the human brain as there are grains of sand on the beach. And I sat there thinking, what beach? All the beaches? A specific beach? How many grains of sand are on a beach? How do you know how many grains of sand are on a beach? I was like completely lost by his example. I just could not understand, because that doesn't help me. I have no idea how many grains of sand are on a beach any more than I know how many neurons are in a brain. I've also heard that there are as many neurons in our brains as there are stars in the universe. Well, I don't know how many stars are in the universe. I mean, these things don't help. They're just one abstract example compared to another abstract example. So luckily for me, email provided a nice concrete example. You guys are probably mostly young enough to not have ever had the pleasure of the email chain letter, where instead of just posting your meme on Facebook or Instagram, people would pass these on in forwards, and you would get these horribly formatted emails that would show us things. So this one came to me first as an email, and then I found it on the internet. So what does $1 trillion look like? So I just mentioned I have no idea. So here we have a $100 bill, which I think we can all imagine. Okay, a single $100 bill. Now, if we stack them up half an inch thick, that's going to be $10,000. All right. So $10,000 is a little packet of bills, $100 bills. Okay, now this small pile here at his feet is 100 packets of 10,000, which makes $1 million. I have to say I'm a little unimpressed with the $1 million pile. I thought that should be bigger, but okay, I'm with you. That's what $1 million looks like. Now this stack is 100 million. So we've taken 100 of these little stacks, put them onto this pallet, and this is what $100 million looks like. All right. Now we want to represent $1 billion. So now it's going to take this many pallets to make $1 billion. This was 100 million. This is $1 billion. Okay. So now it's time to represent in these same kind of scale $1 trillion. So keep in mind, our guy has been standing in the same position right next to the thing. So keep in mind, he's going to be our rubric for how tall things are, how big things are. So let's scroll down. I always like this dramatic drum roll, please, as we scroll down. Keep scrolling. All right, here's our $1 trillion. This giant thing, and there's our guy. So that gives us a perspective, right? He had been so big compared to the $1 million, and now here he is compared to $1 trillion. So everything's been held stable as far as, the number of pallets and all the things. Notice that the pallets are too deep. So we've got 2 deep worth of however far and long these pallets are. And then let's remember that our debt clock was at 24 trillion. So we need 24 of these. Okay, now we've really started to move out of, I still can't. Now we get into 24. I don't even know how tall that would have to be to just take this. You'd have like a 5-story building or something to make this 24 deep, I think. It's a lot. It's a little easier to wrap our head around than just looking at this debt clock, which has gone up $1 million at least since we've been talking, right? It's at least a little bit more concrete. I guess that's the goal, right? The concrete information always has a bigger impact on us than abstract does, because we can really wrap our minds around it. So testimonials are persuasive because of these vividness effects. So I thought I'd share with you a psychological study that sort of examined these vividness effects. So McCabe and Castell did this brain scan study, and I put brain scan in quotation marks because it wasn't a standard report that needed brain scans. It was a test of whether people believe things more when there are brain scans included. So what's more convincing than talking about brains? Pictures of brains. So this isn't the original study. This is from a science blog, and I just like their presentation of it. So what they did is they gave students one of 3 versions of the exact same article. Yeah, in one article, it was just the text explaining that the same area of the brain is activated while doing arithmetic or watching TV. So they came to the conclusion in the report that watching TV and doing arithmetic are somehow related activities. So for 1/3 of the participants, they just read an article that said that. For another third of participants, they read the article, but now it had a graphic that illustrated the relationship between the brain and the brain. A little graphic that showed how performance on arithmetic and performance on TV viewing were related. And then in the third version, they showed a picture of an actual brain scan. Yeah, they don't have it here. The image used to be here on each of these, but apparently their links have gone dead. So 3 different conditions. You just read the article. You read the article with a graph that, illustrated the findings, or you read the article and it had a picture of a functional MRI of a brain. Okay. What they found, our little results are here, but unfortunately it doesn't have the graphics. But what they found is that the students rated the credibility of the article significantly higher when it was accompanied by a brain image than when it was simply text or when it was text plus a graph. So people trusted it more just because it had a picture of a brain scan in it. It's vivid. I can see there's a brain scan. It must be about a brain. It must be, you guys did actual science here, right? Like it makes it seem more meaningful to have something concrete there. So this study kind of illustrates this idea of vividness effects. Now I just thought I'd throw in as an aside, we got a small problem with brain imaging studies altogether that was recently reported in Discover magazine. Researchers in Sweden and the UK landed in the news over the summer, it was 2016, seeming to claim nearly 40,000 fMRI studies could be invalid. The problem? The most popular statistical analysis software packages could indicate significant brain activity where there wasn't any, more than half the time. So, of course, we're very concerned about it. It turns out that, we're not sure exactly how many studies that have been published actually relied on the software that they're talking about. But the software is critical for taking the signals that are coming out of the brain and colorizing it so that it's interpretable by the humans, right? So if the brain imaging software is faulty, all the conclusions would be faulty. So to think that it gives more credibility to see a scholarly article, including a brain scan, and then to know that the brain scans that do exist may be faulty, takes us down a horrible rabbit hole. Anyway, back to what we were talking about. So all of this discussion on pseudoscience is to get us set up to be excited to hear about controlled studies. To put ourselves into a mindset where, we don't want to be doing this kind of pseudoscientific or junk science kind of stuff. We want to be doing good, controlled, unbiased studies. So when we talk about controlled studies, we're talking about the gold standard would be to have a placebo control condition. So not just a control condition where we sort of just hold them steady, but a control condition that thinks they're getting the treatment. That's like the gold standard of all controlled studies. Now, there are 2 different ways to do placebo controls. There is the single blind way, which is the most common way of doing a placebo control. And that's where the participant doesn't know whether they're getting the treatment or they're getting the placebo. That's single blind. And it's the participant who's blind. I gave you an example here of an old dating show from the early 00s where Monica Lewinsky was the host. And there was a woman who all the male participants could see her. And then they always had to wear a mask whenever they were around her, or they'd have to meet in complete darkness. And she was supposed to be picking her romantic partner from personality only, right? Like she's blind to them and they were not blind to her. So this was a single blind case. There's actually a modern dating show that involves them both being blind, which is a good example of a double blind, but I can't remember the name of it, so I couldn't search for it. But it's in a double blind, the participant is, of course, blind, doesn't know whether they are receiving the treatment or the control. And then the researcher who comes in contact with them is also blind. Now, there would be an overarching research coordinator who would know which group is getting the treatment or which individuals are getting the treatment. It's just that we want to keep the person who's in contact with the participants blind to conditions so that they don't accidentally treat the participants differently because they know these are the experimental participants and these are the control participants. We don't want them treating them differently. We don't want them to score them differently on some measure because they know that, well, these are the ones who got the treatment, and so they should be performing differently. And these are the ones who got the placebo, so I should give them the same score I gave them the first time because I know, like, I don't have to work as hard because I know that they got the placebo, so I don't even have to really work at it. You don't want people doing that kind of thing. So, and sometimes you don't do it on purpose. Sometimes the researcher is just accidentally sort of acting differently because they are aware that this is the experimental group or this is the placebo group. So one way to protect against that is the double-blind design. I'm going to give you a bad example from the media, but there was an episode or a series of episodes of Grey's Anatomy a number of years ago, probably 10 years ago now, where McDreamy, I can't remember anybody's names, McDreamy was doing a study of Alzheimer's patients, and he was a neurosurgeon, so he was going to do some kind of implant of something. I don't recall what exactly the treatment was. So he had these volunteers who had Alzheimer's, and they were very careful to make sure he didn't know which patient he put the treatment into and which patient he put the placebo into. So everybody got some kind of, got the same exact brain surgery kind of condition, but only some had the treatment inserted and some had a placebo inserted. But here's where it went a little awry. So he didn't know, but here's the problem. His girlfriend was the person who was going to be doing the assessments of the patients afterwards to check them for symptoms of Alzheimer's and stuff like that. So she was the one who had gone to the refrigerator where they kept the treatment and picked the control or the placebo or the actual treatment and gave them to her boyfriend, who then inserted it. So she knew which patients had gotten the placebo and which patients had gotten the treatment. And then she was the one who was assessing their symptoms after the fact. And of course it was a drama. And so the worst thing happens. She kind of fudges the data for the treatment condition to make it look like when in doubt, I will score this as evidence of improvement when it's the experimental group. And when in doubt, I will score this on the side of evidence for worsening condition, for the placebo condition. And that's exactly what she did. And that's exactly the risk if you don't have a double-blind setup. So now the thing is, the double-blind setup's a lot easier to do in medical research. It's a lot easier if you're giving people pills to take and you can make an active ingredient pill and an inert substance pill look exactly the same, put them in the same packaging. And, it's a lot easier to do that than it is to give a placebo psychological experience. It's very difficult. I do research on memory. And one of the things that I did when I had members of the experimental group and the control group both being tested all in the same room, the experimental group needed to do a recall test, and I didn't want the control group to do their recall test till I came back for the follow-up study. So I couldn't have half the group writing stuff down and the other half not writing stuff down because that would alert them to the differences in their conditions. So I gave a placebo. I had the experimental group write down what they had just learned, and I had the control condition write down the names of as many U.S. presidents as they could remember. So they were doing a memory task. They just weren't doing a memory task involving the material they had just learned. So it's possible to have placebos. It's possible in psychological research, but it's just so much easier when you're doling out pills or giving injections or even brain surgery. It's so much easier to do it in those situations than it is when you're talking about behavioral differences. So here's an interesting question. Here's the graphic from the McCabe and Castell brain image study. And so you see that the text condition and the bar graph condition rated the scientific reasoning the same, and the brain image condition rated it higher. Okay. But here's the question. What's the placebo condition in this study? Well, see, this is what I'm talking about. What would be the placebo? And here's the really weird thing. We might have said, as McCabe and Castell, we might have said to ourselves, Okay, so we think that people might be influenced by the presence of a brain scan. So we think, whether it's a text alone or it's something abstract like a bar graph, they'll see the same kind of scientific reasoning, but the brain image, that'll really be the different thing. So we might have set it up with two control conditions, text and bar graph, sort of setting up in our minds that abstract things like text and bar graphs will be rated differently than something concrete like a brain image. But we also could have made an argument that visual stimuli might have given higher ratings. So we might have expected the bar graph and the brain image to produce higher ratings than text alone, because we're like, well, there's a visualization going on with the bar graph and the brain image. So I would argue that they probably were thinking the text only was the control condition. That's my guess. They had to have been thinking the text only was the control condition. And that really that bar graph was the wild card. We weren't sure if it was going to benefit from being a visualization or if it was going to, have the deficit of being, not as vivid. So I don't know what they thought exactly. I never asked them, but it definitely looks to me like text is probably placebo for sure. And then bar graph is a bit of a wild card. And that's the thing in psychology, right? Was it single or double blind? Probably it was single blind, where only the participants were unaware of the fact that there was these three different conditions. Probably the researcher was the same researcher and knew that there were the three conditions. But you can imagine maybe they set it up as a double blind, and the person handing out the article to read, maybe it was in an envelope, and that person didn't know, am I handing this participant a text only, or one with a bar graph, or one with a brain image? You can imagine they could have done it double blind, but my guess is the way that most of us do our research, it probably wasn't double blind. So I'm going to finish up with, what is the purpose of the placebo or the control group? It could be a placebo control, or it could be just a control where there's no placebo involved. What's the purpose of this? Okay, let's say that we're going to test the efficacy of Proactol as a diet aid. So let's say first off, we randomly assign participants to either be in the control group or the experimental group. And then we give them their dose in this exact same packaging, but the placebo control group gets a non-active ingredient and the Proactol group gets the active ingredient. And then let's say that the experimental group really does lose more weight than the control group. We can conclude that the treatment was effective and that the performance was not due solely to participant expectations, because we have that control group who should have been benefiting from those participant expectations, right? They thought that they were taking the active ingredient, but they didn't lose as much weight. So because we had control over things, we can say that it was not due to expectation. The treatment is the explanation for the outcome. Okay, what happens if instead the experimental group and the control group score the same? So either neither group loses any weight, or they both lose weight, something like that. So we've got an experimental group and a control group that score the same. One interpretation is that the treatment is not effective. So if neither group loses weight, we could say, well, this Proactol doesn't work at all. If both groups lose weight, and that's why they score the same, we could make the explanation that participant expectations may be the reason why both groups lost weight. So that's the benefit of having a control group, because if the control group performs exactly the same as the experimental group, we're going to have to make the argument that the expectations may be the powerful factor, right? And so that's why we have those control groups, so we can separate out what actually worked from what might just be solely due to expectations. So use of a control group is critical to actually being able to answer whether what we're claiming is true or not. All right, that concludes this chapter, so I will see you guys in the next chapter.